Hello, everyone. My name is Carlos Morales. I run AI for Ambiq. Along with the silicon, of course, you get a lot of software. So we have versions of Apollo that have extremely low power Bluetooth, and you get a software stack with that. There's security, of course. TurboSpot is a way of controlling dynamically your power utilization. So going to 200 megahertz when you need it, dropping to 100 megahertz when you don't. Specifically, it's 192. That's we round up. So I think it's 96 and 192 or something like that. Turning peripherals on and off as you need them, because we're all kind of power obsessed over here. We have a part of the stack that enables speech UIs. We have a easy way to program our graphics, very sophisticated graphics processor. And then we have a library of neural network helper functions that help you get AI running on your chip quicker. That's all built on top of a common SDK. And the SDK abstracts all the or makes easy to use all the peripherals that we have on our SoC, memory, RF, and so on. If you've been in Silicon Valley for a long time, especially if you've been in the semiconductor field, you've heard folks dabbling in subthreshold before. It's easy to get working in a lab. It's super hard to get it working in real world situations. So in the lab, you control temperature, you control power, you control everything, right? In the real world, you can't tell your user, hey, your watch is getting too warm, stay out, right? It has to work when you're running, when you're in the sun, when you're in the shade. It has to work when the battery's fully charged and when it's not. Those voltage variations have to be taken into account. And you're printing thousands of parts on a wafer. So making all of those parts run equally well in this domain is also difficult, right? So these are the problems that Ambiq has solved and productized as a way of productizing subthreshold. And the payoff is you get that 16x better performance. What's driving the future of wearables? It's practicality. Being able to do real things without impacting your battery life, or extending your battery life and doing the old stuff you were doing, right? Having a sophisticated graphical capability, so you can actually do dazzling, pretty graphics on your wearables or on your wall devices and so on. Having speech as an input, so you need good sensors, good audio kind of converters, and you need sophisticated compute behind that. And then you tie it all together into multimodal models that are looking at different sensors. And you can start doing sophisticated things like fitness tracking, but also seemingly simple things that are actually super hard to do right. Fall detection. You don't want false positives or false negatives. Fall detection has to be one of those things that's super accurate. Lives depend on it. And it turns out that just looking at one source or another is not sufficient. So you need sophisticated compute, multiple sensors, and efficient ways of sampling those.